Let's take a look at another example of solving a nonlinear system of equations. If you want to take a look and identify the type of conic sections we're dealing with, it appears that the first equation is a circle, and the second equation is a parabola. And actually, it's a horizontal parabola because I know it's solved for x, and it looks like it should be opening up towards the right. So at least that gives you kind of an idea. Now, they didn't specifically say, you have your choice here because it just says round your answers to the nearest hundredth. So yeah, you can solve it analytically if that's faster. Sometimes it is. But it kind of gives you permission when it's asking you to round your answers to the nearest hundredth. I would say it's okay to use your TI to solve it graphically. So you're going to kind of notice, you're like, okay, if I can use my TI to solve graphically, the first thing I'll have to do is solve each equation for y in order to graph them. So the algebra in that sense, sometimes maybe that promotes you to say like, oh, maybe I just want to solve it analytically because I'm going to be doing the same amount of work. It's kind of like you have to pick what works best for you. But I'd like to demonstrate this with the TI so that you can see we don't really need the exact answers because it's not particularly asking for them. So in order to do this type of problem, let's start off first with the circle. And I'm going to solve it for y. And we've had practice in this with the previous chapter, and you're kind of wondering why we were doing that in the previous chapter. It's all for today. So if I'm going to solve the circle equation for y, I'm going to leave the y minus 1 square on one side. And that would involve me subtracting the x minus 1 square from both sides. So that will leave us with 4 minus x minus 1 square. To solve for y, we still need to take the square root of both sides. So I'll erase that to kind of help you. Oops. So if we take the square root of both sides, we have the square root of the right-hand side, or excuse me, left-hand side will give me y minus 1. Square root of the right-hand side, we have to remember to include that plus or minus. So this is going to leave us with the square root of 4 minus x minus 1 squared. And now to solve for y, we're going to add 1 to both sides. So remember, when you add 1 to both sides, it's outside your radical. So be careful there. So we have y equals positive 1 plus or minus square root of 4 minus x minus 1 squared. So now, because we have this plus or minus, what's going to happen is this is where you end up saying, okay, that means that I get a y1 is the positive case, 1 plus square root of 4 minus x minus 1 squared. And y2 will equal 1 minus the square root of 4 minus x minus 1 squared. So we can take some time to enter those into our calculator, and then that's a nice little break. So then we go back and we'll do some algebra for the second equation. So we have y1. I'm going to refer back to these quite a bit. Move on to our calculator. Remember, we're going to press that y equals button, and we will enter in our numbers. So the first thing, I'm going to look to see what I got. I have 1 plus, I got to look at my screen. It's a little small, but it's the square root of 4 minus x minus 1 squared. So you can use the exponent key to get there. So that is your y1, and I'll double check just in case on the side. I'm feeling good about that, okay. And then press enter. And now the y2, I know we wish there was a copy and paste button, but so far we don't have one. It's the negative case, 1 minus square root of 4 minus x minus 1 squared. Now you can play around and change these all to the same color if you're interested. I'm just gonna take a quick check. When I was looking at this particular equation, what I'm supposed to see is a circle. So I'm just gonna graph it really quick to see if I in fact do see a circle. And I do. Top half and the bottom half. So I'm feeling pretty good that we're in the right, we did the right algebra and all. So we need to figure out the intersection of this circle with the other equation, and that's the parabola. So we're gonna go back and we're gonna do a little more algebra to get those entered into the TI. So now if we're gonna deal with the parabola, we are as well, we're gonna solve it for y. And it's too bad it's not already solved for y, it's solved for x, but that doesn't help us. So let's write it over again. It is at x equals, well, we can do this really quickly. If you wanna solve it for y, might be easier to subtract 2 on both sides. So you'll end up having x minus 2 equals y minus 1 squared. Could be nicer. Then if you prefer, because I know a lot of us like to work on the left-hand side, you could just kind of reverse the equation a bit. That kind of makes it easier. You want to solve for y, we still got to undo the square. So we take the square root of both sides. That will leave us with, I'll move this up a little bit. We will get y minus 1 on the left-hand side, not forgetting the plus or minus case of the square root of x minus 2. Very last step to solve for y, we're going to add 1 again. Add 1 to both sides, keeping in mind it's not connected to the radical. So finally we have y equals 1 plus or minus the square root of x minus 2. So that's a little nicer, I guess. But keep in mind, because you have the plus or minus, this is going to end up with us entering it separately into 2 different equations. So this is going to leave us with, depending on what colors we have them set at, I have y3, 1 plus square root of x minus 2. And I guess my y4 is like pink or something like that, but I'll go with orange. y4, 1 minus square root of x minus 2. So let's go back to our TI. We'll enter that in, and hopefully it's supposed to look like a horizontal parabola, so we'll make sure. That's the kind of the good thing about knowing conic sections before you approach this. You can definitely verify if your algebra is correct. So let's go back to our y equals, and I'm going to go all the way down to y3, and it should be 1 plus square root of x minus 2. And 1 minus square root of x minus 2. So if we graph it, we do see it is a parabola and it is opening up to the right like we thought. So this is good news. If you'd like, I'll copy this over. Well, if it'll let me copy it over, we'll see. And I just want to point out, we'll see if it'll let me, that what are we really looking for when we're going through this? So let's see if I can copy it over. Sometimes it lets me and sometimes it doesn't. Oh, good. Today we're having a good day. Right, Leica? Right. Let me raise this up a little bit. There we go. Now, if you're solving graphically, you're probably no stranger to this. What we are in fact looking at are the intersection points of our circle and our parabola. Now, it may be hard for you to see in our particular picture, but we do see that there are 2 intersection points. So that's our job to calculate them. Now, sometimes if you're zoomed too far out, it gives you a hard time with finding them. So there are cases where you need to zoom in order to find them because maybe you're too close. I also want to point out we're going to have to use the toggle function to jump from each of the graphs, y1, y2, y3, y4. So kind of, we can now see we have y1, y2, y3, and we have y4. So let's kind of discuss that. If it's working out well in our calculators, that'll be great. Let's go through that. Let's go back to our actual calculator. There we go. Now, if we're going to calculate the intersection, you are no stranger to this. I will press second graph, or I should say second calculate, that's second trace. And we're looking for item number 5. Oops, excuse me. Clear this out again one more time. We got a little crazy here. So again, let's try this one more time. Second trace. We're going to calculate the intersection. That's item 5. And now it's asking for first curve and second curve. So I like to get closer to my intersections. Not too close. I just need to know I'm on the first curve. So pay attention to what it says on the top. If you're not in color codes, I do have y1. I'll press enter. Now notice it jumps to y2, and we do not want the intersection of y1 and y2. I'm really concerned with the intersection of y1 and y3. So in order to get to y3, you either have to press the up button or the down button to get there. So I'm going to press the up button. That's going to get me back to y1. I press the up button one more time. See how it jumps to y4. Press the up button one more time. It should give you y3. Now, unfortunately, we don't quite know where we're at. It looks like there's no y value, and that's the limitation of the calculator. But as soon as I press the right or left arrow key, I'm looking for that particular intersection. So I'm feeling pretty good that I'm looking for the intersection of those two curves. I'll press enter, and I make it guess. And let's kind of figure out what happened here, because sometimes we end up having issues. This is a case, and I'm glad it happened while we're doing this. Sometimes you do have to zoom in. So I think I'm going to do that because it does give me some issues. So let's see. Let me graph it again. Let's zoom in to where our particular intersection is, because maybe we didn't go closer. So I can use 2. I press the zoom button. I press 2. And it doesn't hurt. Kind of move a little closer to where you think your intersection will be. That sometimes solves the issue. So if you have kind of a bigger picture, now it's a little nicer. Let's try this again, see what happens. Second trace. I'm going to calculate the intersection. We are on the first curve, we're pretty happy. But notice we kind of go through the same thing. Let's press up one more time. Back on the second curve, press up. We're now on y4. Press up, we're now on y3. So I'm feeling pretty confident that this will work. Let's cross our fingers, make it guess. And I have a bad guess. Press a valid guess between the upper and lower bounds. Okay, we'll try this one more time. Let's go back. Sometimes technology doesn't work for us. So like I said, let's go. All right, let's see. Where's my first curve again? Maybe I'll switch off my first curve. Sometimes that's an issue. So let's go a little closer to our intersection point. Maybe that's kind of the issue. Calculator has its issues. So let me go real close to the intersection point. I'm going to jump up. Sometimes it might be going too far into the second curve. This is good. Okay, so I'm y1, y4. Let's do this one more time. And if it's giving, yes, now we have it. Yeah, so you'll see, even with my experience, it does take me a few times to try. And I'm guessing what I was playing with earlier, if you're too far away from the intersections, your calculator doesn't quite know where to go. So maybe zooming in a little bit more and then going as close as you can to the intersection point will help you. But this is the correct answer. So usually if we are taking rounding to the nearest, I think it's 100th, I'll write down what I have with 4 decimal places just in case. And then we'll go from there. So I'm taking note right there. 2.79123, or excuse me, or 2.7913 and 1.8895. And I think it says round to the nearest 100th, but we'll do that when we get back to our screen or our paper. Let's do this one more time for the second intersection point. So that's over here at the bottom, the red and the pink. So second trace, again, intersection. And this time we want to get the red curve. So I'll press the down key and now I'm on the red curve. And I'll kind of play around, see if I get a mistake again. We'll go from there. So that's our first curve. It jumps to the Y3. Go down, we'll jump to the Y4. There's my second curve. Let's see if it lets me work this way. Let's make it guess. And you see how like sometimes it's like it's too far off. Let's try it again. Let's see if we go from there. So second trace. No, first of all, we gotta quit. They say never give up, but in this case, it's okay. So we got second trace one more time. We're gonna calculate the intersection. And I'm gonna do the same thing is try to match as far as I can on top of my intersection point. So let me go to the pink part. That's the pink one. I'm gonna go as close as I can. Sometimes that's the issue. It's really nice being color coded because it kind of tells you what curve you're on, but you could also pay attention to the top so you know where you're at if you don't have the colors. So that's our first curve. I want to go to the red curve and I'm right on top of that. Let's see if that works. And we now see that our calculator is no longer being finicky. So sometimes you got to treat it well for it to work for you. And this is the case of today. So I'm going to write down everything kind of to 4 decimal places since that's usually my standard, 2.7913, 0.1105. And then we're going to go back and see what the directions were. So I hope you have some experience with this. Like I said, don't be afraid to zoom in, go a little closer, try it a few times. I'm so happy it happened in front of you. Like I said, nothing's perfect all the time. So we'll work on this. So let's go back. We're almost there. And the first point we saw, I have the X value for this one, the top point. I think I got 2.7913, 1.8895, and then the bottom point 2.7913. So they're symmetric about the x-axis at least. 0.1105. Now double check one more time. We're going to look at the directions, and I suspected it was the nearest 100th. So that's all we have to do. Take our answers. We're going to round them. There's 2 solutions to this particular system of equations. This is going to be 2.79 and 1.89. And the other solution rounds again to 2.79 and 0.11. So take your pick. I kind of like the visual from the system of equations to help me out with finding the answer. You did have the option. It did not specifically say graphically. You could have solved it analytically using a kind of an elimination or a version of substitution. But keep in mind when you use the quadratic formula, you'd probably have to approximate. So we're still going to get the same answers. I don't know which one takes longer. I kind of feel like the quadratic one might take longer, but never know. And if you do solve graphically, make sure you draw a quick sketch of your graph so that we can verify like, okay, everything's good. So I hope this helps you. Feel free to try these. I think a lot of the problems in the homework are asking you to use your calculator to solve the nonlinear systems. So you might as well practice now, and then you'll have a good time with the homework. I hope this helps. I'll see you in the next section.